Riddle me this, mother lecker.
Here's a fun little algebra problem solved for all real numbers x, for which x squared minus 7x plus 11 all raised to the power of x squared minus 13x plus 42 is equal to 1. A similar problem was given to high school students in Massachusetts with an average of 30 minutes to solve each question. Can you figure it out? Give this problem a try, and when you're ready keep watching the video for a solution. So how can we solve this problem? Well, imagine that you're stuck on this problem. Many students today will check on apps and websites to find step-by-step solutions before this problem. Interestingly, many computer solvers do not give the correct answer. Photomath, which has over 100 million downloads, cannot solve this problem. It doesn't provide step-by-step solutions, and its graph would suggest that there are 4 solutions. In fact, there are 6. Similarly, Mathway and Symbol Lab are able to find 4 of the solutions, but they miss 2 of the solutions. A graph on decimals would suggest that there are 4 solutions. But as I'll demonstrate in a minute, there are actually 6 solutions to its credit. Alpha is able to find all 6 solutions, but since solvers can miss solutions, we definitely need to check and solve on our own. So how can we solve this problem? We will work case by case and remember our exponent rules. So one way that we can get a result of 1 is if we have 1 to the power of any number that will be equal to 1. So we need to set the base equation equal to 1. This would imply that x squared minus 7x plus 11 is equal to 1, and we can factor this to get the quantity x minus 2 times the quantity x minus 5 is equal to 0. This gives the 2 solutions of 2 and 5, but this is not the only way we can get a result of 1. Another case is if we have any non-zero number raised to the power of 0 that will be equal to 1. So we can set the exponent equal to 0. This implies x squared minus 13x plus 42 is equal to 0. We can factor this into x minus 6 and x minus 7. This will give 2 solutions of x is equal to 6 and x is equal to 7. Now we also want to check that the base is not equal to 0, because 0 to the power of 0 is an indeterminate form. So we quickly do that and we see we have no problem. So in fact x is equal to 6 and x is equal to 7 are also solutions. But there's one more way that we can get a result of 1, which all of the solvers except Alpha missed, and this is the case where we have -1 raised to the power of an even number that will be equal to 1. So we need to set the base equal to -1, and we need to check if the exponent is an even number. So we set the base x squared minus 7x plus 11 equal to -1. We then solve this equation by factoring, and we get 2 solutions of x is equal to 3 and x is equal to 4, and I should say there are 2 possible solutions, because we then need to check that the exponent is even. So we check that the exponent in each of these cases will be an even number, and 12 and 6 are even numbers, so in fact x is equal to 3 and x is equal to 4. Our actual solutions, so these are the 6 solutions to this problem. X is equal to 2, 3, 4, 5, 6.
Riddle me this, mother lecker.